Students, this is the finals review packet, help video, units 3 and 4. Taking a look at this first one, I know it's been a while since you've seen this, so let's go through the gestures. The gestures are exterior, sum, remote, interior. What this is saying is when you have an exterior angle in a triangle, so that's by dragging out one side here, that angle, the exterior angle, is equal to the sum of the two angles that are far away but still inside the triangle. So, for example, those two blue angles add up to the red. In this problem on the left, it would look like this. This exterior angle is equal to the sum of the two remote interior angles. Obviously, we want to solve for x here. Circle, plug, chug. Be careful here, it doesn't just want x, we want the angle TDE, which is this angle right here. So after you solve for x, you're plugging it back in and then finding the angle. These guys you should be familiar with. When it says how you know they are congruent, what we're looking here for is side, 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 angle, side, angle, side, angle, and of course, angle, angle, side. And I expect to see marks like this, trace, trace, go over the hatch marks, side, sweep the angles, angle, find the freebie, side. I expect markings on the diagram there. Problem like this, we just did these, two equal sides, two equal angles, two equal arms, two equal elbows. Watch out also for linear pairs like this one right here. Two equal sides, two equal angles. So if there's two equal sides, this angle and this angle are equal. Well, of course, to get the yellow angle, you add 73. Take it away from 180. I expect to see all this work. And then watch out, that's 34, that equals 90. So the main thing here you want to watch out for are these things. One, linear pairs add up to 180. Watch out, there might be vertical angles which are congruent. Complementary angles which add up to 90. And two equal sides, two equal angles. It's like find the segment indicated. Doesn't tell you how to do it, so you have to ask yourself, what is it you notice? We're going to find IK here. Well, what we notice is that F is the midpoint going this way. E is the midpoint going this way, which makes FE a mid-segment, which means it's parallel and half. So it takes two FEs to make one KI. There's your thing equation. This is a one bunny hop, two bunny hop, mid-segment. And you circle, plug, chug, and solve for x and solve for the length indicated. We're told here that this is an angle bisector. So there's two things that are true. We know that the measure of angle HFG equals the measure of angle 1 plus the measure of angle 2. We also know that angle 1 is congruent to angle 2 because of the bisector. So right here, we're going to circle plug chug. Angle 1 is 6x minus 5. This bigger angle, we're told, is 9x plus 5. And where can we find the measure of angle 2? Well, 2 and 1 are the same, so I can just double it. Obviously, you're solving for x, but you're not done when you solve for x because it's asking you to find the measure of angle 1, which means you have to plug x back in there and solve for angle 1. Said the two sides of a triangle have the following measures. Find the range. So the rule is, I called it clown face, eyebrow, eyebrow, smiley. So we have 9 and an X, 11 and an X. So what we're saying here is what is the range of possibilities X could be. That's a range. That would make this a triangle. So any two sides have to add up greater than the third side. So you have to do all three combos. 9 plus 11 has to be greater than x. Eyebrow, eyebrow. 11 plus x has to be greater than 9. Smiley, 9 plus x has to be greater than 11. And you solve for x. That, of course, is going to be 20 is greater than x. We minus 11 both sides, which makes that negative. So we're just going to toss it because you can't have a negative length. So x must be greater than 2, but less than 20 in order for these to form a triangle, not a right triangle, just a triangle. State to see if the triangles are similar. If so, how are they similar? And complete the similarity statement. So you want to match short to short, long to long. If you have overlapping triangles like 24, you want to pull them apart. So we're going to pull this apart. So I'm going to do 156 minus, to get this black squiggle, 156 minus 131. And I get 25. And of course on the right hand side, that's 130 minus 120, so I get 110. This whole side is 156. This whole side is 130. So you want to see if it can be reduced. They do share this angle in the middle, so we know we at least have a congruent angle. Let's check the ratio of the sides. Let's see. Obviously, 5 goes into both of these. So 5 goes in here 5 times. 5 goes in here. $22 times, so it's 5 and 22. Whoops, wait a minute. I did not physically trace. I take that back. Back. We were given the right-hand side. It's 20. It's not minus 20. It's just 20. So that's going to be 5 goes in there 5 times. 5 goes in there 4 times. Now you take a look here. It is impossible for this to be a 5-to-4 ratio because 156 is not a multiple of 5. So the ratios are not equal. Therefore, these triangles are not similar. This one, it's all solve for x. You want to match and mirror. So this 16 matches with 2x plus 4. This 10 matches with this, which is 24 minus 16, which would be 8. And you make a proportion. Cross multiply and solve. Medians. So be very careful with this. What's basically, remember what's going on here is this in the middle is a 1-to-2 ratio. So it's talking about CU. That's UF is 1 bunny hop and CU is 2 bunny hops. So what is the relationship of CU? CU equals 1/2 UF, or another way you can express it would be 2 UFs equals 1 CU. That'd be another way of expressing it. So I'm going to use this one down here so I'm not distributing a fraction. 2 UFs equals 1 CU. You solve for x, and then it wants you to find the entire thing there, the entire segment after you solve for x.